Welcome and thank you for standing by. Today's call is being recorded. If you have any objections, you may disconnect at this time. All participants are in a listen-only mode until the question and answer session of today's conference. At that time, you may press star one on your phone to ask a question. This call will begin momentarily.
Welcome. This is Karen Fox with the Office of Communications at NASA. Thank you so much for joining us today for this media telecon to discuss what has been happening with the James Webb Space Telescope since its launch, walk through some more details about the deployments over the last week and a half. The team is working literally around the clock, and they are working deployments as we speak. So we just have a couple of people here to talk and answer questions. Because time is limited, they will speak quickly, bring you up to speed, and then we'll leave most of the time for questions. Many of you know this and have done these before, but go ahead and press star 1 if you want to get on the list to ask a question. We will take those towards the end. And with that, I will turn it right over to our experts today. We have Bill Oakes, the project manager for Webb at NASA Goddard. We have Amy Lowe, the vehicle engineering lead at Northrop Grumman. We also have on the line available to answer questions later if needed, Greg Robinson, who is the program manager for Webb at NASA headquarters. And with that, Bill, take it away.
Okay. So as Karen mentioned, we have been working around the clock since actually before we launched, doing 12-hour shifts. A couple things I want to point out. One of the things that we do is we make sure we balance the hours worked of our folks versus making sure they're not getting too tired. For example, our deployment team one day worked a 14-hour day. So regardless of where we were going to give them the next day off and take a break. The other thing I wanted to point out is that, and it came out, I think, in a blog post yesterday, is that we are still in the getting to know you phase with the telescope. All satellites will always be a little bit different on orbit than they are on the ground, and it takes time to get to know that, understand their characteristics. And that's a lot of what we've been doing over the last week, as well as still making excellent progress on the commissioning timeline. Over the last couple of days, we have deployed the unitized pallet structures. That's the structure that holds the sun shield before we start to unfold it. We raised the telescope up off the satellite with our deployment tower assembly to allow us to deploy the sun shield. We deployed the aft momentum flap. We rolled back the covers that protected the sun shield during launch and ascent. And most recently, we deployed the mid booms and pulled that sun shield out. And I am pleased to say that today we are actually starting the tensioning of layer 1. We will complete the tensioning of all those layers over the next 2 to 3 days. So it's not, again, we take our time and allow for flexibility in the schedule to understand what we're seeing when we look at the data coming from the telescope. There were 2 concerns that we worked over the last couple of days. One, dealing with the solar arrays, where a preset max duty cycle in the array regulator module was basically limiting the output of our solar arrays. And they could not keep up with ongoing observatory activities, so we started to draw down on the battery. The other concern was that some of the motors that we'll be using today to tension layer 1 were running at a higher temperature than their operating temperatures. They were fine from a qualification point of view, but higher than what we'd like for operating. And for both the details on both of those, I'm going to let Amy address both of those as far as describing the problem and how we got the resolution to those issues.
All right, thank you, Bill. Hello, my name is Amy Lowe, and first I'll talk a little bit about our power subsystem issue. So like Bill said, the solar array had a factory preset duty cycle, and the team always knew that once we got on orbit and, like Bill said, understood a little more about our power subsystem and how it operates on orbit and got all the characteristics, that we would perform a reset from the factory preset duty cycle. And so as we got on orbit and understood what temperatures the arrays were operating at, exactly what load it was expected to see, we then went ahead and made the decision that we did want to what's known as rebalance the array and set the duty cycles so that each array and each panel of the array, we have 5 panels on the array, each panel of the array could be optimized to work at their best duty cycle possible. And so in order to do that, because we're engineers and we're extra cautious, what we did was we asked our team back at the factory to run the exact as measured temperatures for each of the panel on the simulators that we have back home in factory. I work at Redondo Beach at Northrop Grumman, and that's where a lot of the factory test beds are. So we ran the exact temperatures that we were seeing on Webb at the factory, ran this rebalancing program that we have on Webb to rebalance the arrays, and they came back and said, this is what we would expect to see. And indeed, yesterday we executed that rebalancing procedure and got the arrays to where they ought to be in order to provide the power that we need on Webb. We're power positive, the arrays look good, the EPS, the electrical power subsystem, everything's green and nominal. And then on the second issue of the sunshield motors temperatures, again, we like to have a lot of operating margin for our motors and, in fact, for anything that we do. And so as we looked at the temperatures of the motors, it did not have as much margin as we would have preferred. One way of cooling the motor is to repoint our observatory so that there was less incident sun on these motors and so that it could have time to cool off. So that was executed last night. We did repoint the observatory, and the motors are cooling off. They're nice and cool. We've got a lot of margin now on our temperature, and the team downstairs is actually executing and operating the tensioning process now using those motors, and we expect it to run very smoothly, and everything so far is looking great.
Great, thank you so much. We will, of course, continue to update on our blogs about the tensioning as it starts and goes on. But with that, let us start taking some questions. So I will toss to our operator, who can remind everybody how to ask a question and can start leading us through the media online. Skylar, if you're there.
Hello, if you would like to ask a question, press star 1. Again, if you would like to ask a question, press star 1.
Do we have any questions? Sorry, go please.
Our first question comes from Elizabeth Howell, space.com. Your line is now open.
Hi, thanks everybody for your hard work. Can you provide some numbers, just what kind of margin that you were looking at for these two issues, like how high it's going compared to what you expected?
Let's see, in terms of the power subsystem, the factory preset duty cycle, I don't know if these are going to mean a whole bunch to folks, but the factory preset duty cycle comes at about 58.6 volts. And in fact, after we finished rebalancing, there's a range of different duty cycles that we reached, and they were anywhere between, I would call it 65-ish to 69 volts. So the change wasn't big, but it was what we needed. And like I said, everything is hunky-dory and doing well now. And just to add, the observatory was never in danger. We were never power starved. This is so that we could have, again, plenty of margin of power. And looking forward to what we will be turning on and operating, the rebalancing of the array gives us, again, quite a lot of margin to the expected increase in power that we will be needing as we, proceed on commissioning. On the motor temperature, we were expecting I think it was, this number I'm a little fuzzy on, I apologize in advance. I think we were expecting about 320 some Kelvin for the motor temperature, and we're currently at about 327. So again, it's not a big delta that we're looking at. Our limits are 340-ish, so we have plenty of operating margin. We're not really expecting any issues out of that. I should also just mention that these are operating margin where we actually run the motor. The fact that the motor temperatures got a little bit high is okay. The motor temperature limit is very high for when we're not operating. So the motors were always very safe. Like I said, we just like to operate them with plenty of margin going, and so decided to move to a different attitude to allow them to cool.
We can take the next question.
Our next question comes from Bill Harwood, CBS News. Your line is open.
Yeah, thank you very much. Two quick ones for me, for Bill or maybe Amy. Can you walk us through the tensioning steps, which layers, the order you're going in, and how long you think it might take to do a layer? And I realize the schedule is flexible and all of that, but just maybe some ballpark sense of that process. And Amy, I don't understand how you rebalance a duty cycle. That's kind of Greek to me. If you could maybe try to put that in terms understandable to a layman, I would appreciate that. Thanks.
Okay, so as far as the layers, I'm not going to go through the nitty-gritty details as far as tensioning goes, but today we are focused on tensioning layer one. Layer one will take most of the day today, so our deployment team will be here most of the day. We'll get through layer one, get that out and deployed. Tomorrow and Wednesday, we will deploy layers 2 through 5, depending upon how each one of those layers go. Will depend on how far we get. It would be nice to get 2 done tomorrow, maybe 3 on Wednesday, but it could be 1 tomorrow, finish up on Wednesday, maybe get a few more done tomorrow. That will depend on how everything goes and the flexibility that we allow, and the fact that we do not want to burn out our team along the way.
And to answer the question on rebalancing the array, so each of our solar arrays, there are 5 panels, and there are regulators that operate on these panels. And essentially what we do is for each of these regulator sets that essentially looks at temperatures of the panel, we sweep through what's known as the current voltage curve and select the best duty cycle depending on the temperatures of the array. So a hotter panel will have slightly less efficiency than a cooler panel, and so to rebalance the array means picking the optimum duty cycle for each of the panels at each of their operating temperature. The factory preset makes all of the panels and all of the regulators operate at the same duty cycle, so it's not very optimized. And the optimization really is just depending on the temperature of the panels and the regulators, picking the right set point.
Thank you. Operator, we're ready for the next question.
Our next question comes from Marcia Dunn. Your line is now open.
Yes, hi, good morning. A couple questions. During the actual deployment of the sun shield, were there any little hiccups or any issues that you had to overcome during the procedure? And how much of a relief was it to get those both sides open all the way? And when do you think the mirror deployment will begin now that you're still working on the sun shield tensioning? Thank you.
I'll address the relief and as the project manager. I'd be wiping my forehead if you could see me. So mid-boom deployment was huge. That was really a huge achievement for us. Obviously, the layering is the tensioning of the layers is obviously the next big step that we go through. I will mention, and I just got some of these numbers just prior to coming in here, when we complete tensioning of all 5 layers, we'll be probably somewhere, and this is an approximation, we will have retired somewhere between 70 and 75% of those 344 single-point failures that were discussed prior to the mission. That is huge within the first week and a half or so of the spacecraft being in operation. As far as what comes next, let's say we finish up the tensioning of the layers on Wednesday. Probably by the end of the week, we will be deploying the secondary mirror assembly, and then through the weekend, we'll be working on getting the wings deployed, as well as there's the aft deployable ISM. ISM is our instrument module. Radiator needs to be deployed. There are some activities associated with the mirror instrument and crowd cooler that we will be doing also. So busy week.
So yeah, let me address surprises. Picking an example, while we deploy our unitized pallet structure, the UPS, and also the mid-booms, well, some of the things that we watch are, for example, the currents off of the motors that are deploying these units. And during ground testing, what we do is we design a lot of ground support equipment that does the offloading, i.e. make sure the mass, because we're in a 1G environment, isn't interfering with the deployment. And so we always knew that based on the ground testing, watching these currents, that we might get some differences when we go on orbit. And maybe I shouldn't be surprised, but I was honestly a little bit surprised at how well these current telemetry that we're getting on orbit matched what we did on the ground. And, you know, each little blip that we expected and the total overall current, they were almost exactly spot on. We plotted it and showed Bill a plot earlier during the deployment sequence. The curves were right on top of each other. So, you know, it was an excellent job by the team that did the ground support equipment. They're unsung heroes. I want to do a little bit of shout out to them. You did an excellent job. The on-orbit telemetry that we're getting matches what we're seeing on the ground, and it's been just awesome, really.
Fantastic, thank you. We can go on to the next question, please.
Thank you. Our next question comes from Jeff Faust with Space News. Your line is open.
Good morning. Thanks for doing this call. I just wanted to clarify that the optimizing the power system that was mentioned in yesterday's blog post was in fact this rebalancing of the solar panel that you've discussed, and if there was anything else with the power system that you looked at, tweaked, or studied in any way leading up to this. Thanks.
Yes, the rebalancing is the optimization, and no, there's no real issues with the power subsystem. This is the only thing we've done.
Great. We will go on then. On to the next question, please.
Our next question comes from Marina Coran with The Atlantic. Your line is open.
Hi, everyone. Happy New Year. 2 questions. First question is for Amy about the 107 pins, those release mechanisms on the sun shield. And this is potentially a dumb question, but when you say that those pins were released, does that mean that they become completely free of the observatory and are ejected into space, or do they hang on and just kind of dangle there forever? And the second question is for Bill. As Mike Menzel said in the latest update, it's not uncommon to learn certain characteristics of your spacecraft once you're in flight. What new characteristics have you discovered so far? Thank you.
Yeah,
Sure, yeah. So to answer the question, yes, all 107 pins have released, and no, they're not ejected into space. We have a little holder where we hold them. We don't want to create debris, so the pins are still with the observatory, but they're no longer pinning the membranes.
Okay, and what we learned, I mean, a lot of it deals around with thermal characteristics. We are finding that, for the most part, our models that we did pre-launch match what we see on orbit. Every once in a while, we see something that doesn't quite match. You want to understand what you're looking at, make sure it's not a problem. And that's really what we've been spending a lot of our time with. It's just, again, it goes back to just understanding certain characteristics of the spacecraft that maybe you just could never have anticipated based on testing and so forth on the ground.
All right, we'll move on to the next question.
Our next question comes from Alexandra Witze with Nature Magazine. Your line is open.
Great. Thank you very much. I just want to stay on this question of the solar panel output for a moment. If I heard properly, and I may not have, there was some talk about the output of the solar arrays was essentially being limited by this issue, but there was a drawdown on the battery. Can you quantify that? Like, you know, how much, what expected percentage of output were you getting instead of what you were hoping to get? And secondly, might this problem of solar panel output occur again in the future, and would it be problematic if it crops up again as you get closer to and deploy at L2?
Go right ahead.
Sure, yeah. So, let me reiterate by saying that we never were power negative. We were always supplying the required power to the observatory. There was never any issues with the power subsystem supplying the right power. So the way, this is getting, I'm sorry, a little bit esoteric, but the way that we have designed the power subsystem is that the battery is in the loop for the solar array. So the battery is sort of always involved. And the fact that we draw from the battery is not an issue. It is designed to operate this way. And in terms of the rebalancing of the array, like I said, the factory preset comes at a preset, and that's sort of the number we knew we had to live with initially during this commissioning phase of JVST. And the rebalancing is something, again, we'd always planned that we had to do in order to get the right power profile for the observatory, especially for the upcoming commissioning activities.
And as far as going into the future, as the spacecraft gets older and older, we will periodically go back in and do that rebalance to take advantage of the capability that we have in the solar array to ensure that it is putting out the appropriate amount of power.
Thank you.
Thank you. And on to the next question, please.
Our next question comes from Irene Kloss with Aviation Week. Your line is open, Irene.
Thanks very much. I have two questions. I think the first is for Amy. The solution that you decided upon to alleviate some of the heating in the motors, is that only going to be applicable for the use of the motors for tensioning, or is this something that you're looking that need to become part of operating the observatory once it's commissioned? And for Bill, I think with the performance you got from the Ariane 5 and the 2 MCC burns at this point, and I know there's a long way to go, but if you were translating the fuel saved into extended life with no other needs for anything else, how many more years beyond the 10 do you think the telescope might be operational? Thank you.
Let me answer that question first, and I'll let Amy come back to hers. Based on our initial calculations, now we know it will be a lot more than 10, and that will be dependent upon also station keeping and so forth. We haven't finished enough of the analysis to give you they'll never be exact anyway, but to give you a more precise range.
And to answer the tensioning question, whether we will be staying at this attitude, no. As soon as tensioning is complete, we are free to go to any other attitude.
Thanks. And if I might just make a comment, we really appreciate the technical information. We understand there haven't been problems deploying, and if you're able to provide these briefings on a more regular basis, I know we'd all be very grateful. Thank you.
All right, we can move on to the next question.
Our next question comes from David Curley with Discovery Channel. Your line is open.
Thank you very much. You said these two problems were things that you kind of expected. The factory settings would have to be rejiggered, et cetera. Has the spacecraft or the observatory sent you a curveball? Have you been surprised by something as you learn how it operates in space?
So, as I have said multiple times, this point in the program only being launched a little over a week, flying a little over a week, we are constantly monitoring and looking at the spacecraft. There are unique things about the spacecraft that we find that we all expect to find on orbit, and it is just part of learning the operational characteristics of this satellite. We're not surprised. We understand that we will find things that we didn't see on the ground, and we look at them, we take a very close look at them, make sure we understand, and then move forward.
Thanks. We'll take the next question.
Our next question comes from Lauren Grush with The Verge. Your line is open, Lauren.
Hi, thank you, and Happy New Year, everyone. I just wanted to get some more clarification about the concern of the temperatures of the sunshield motors. What would be the problem if they got too hot? How would that impact their performance?
Let's see. There's no impact to the performance because they will never get too hot. We have limits placed on the motors that if they get hotter than we like, which is not too hot, remember we're conservative engineers, we never ever push anything to the limit. If they get hotter than we like, we stop. And then we let it cool down, and then we resume when it gets to a temperature where we feel we have sufficient margin.
Thank you. And we are going to try and get through as many questions as we can today. We have about 5 more minutes, but we will take the next question.
Our next question comes from Eric Berger with Art Technica. Your line is open.
Yes, hi, good morning. Thank you for doing this. A question for Bill. When you assess the risk for the entire deployment process, where did the sunshield tensioning rank? Was it near the top or at the top? And maybe you can just sort of give us some sense of sort of the drama that will be unfolding over the next 2 or 3 days as this process plays out. Thank you.
When we go through, if you look at the risk, obviously, and I've made this statement multiple times when talking to folks, when I get asked what keeps you up the most at night, obviously it's the sunshield deployment. Mid-boom deployment was huge. That had its challenges. The next big challenges is the tensioning. That's the best way I can describe it. I don't expect any drama.
We're drama-free.
I always tell folks, operations, the best thing for operations is boring. And that's what we anticipate over the next 3 days, it to be boring. I think we'll all breathe a sigh of relief once we get to the final layer 5 tensioning. But I don't expect drama. Even when we have something that we need to look closer at, whether it's a concern, a problem, whatever, it's not drama. It's done in a very methodical, logical, calm fashion.
Drama-free, I like it. On to the next question, please.
Our next question comes from Stephen Clark with Spaceflight Now. Your line is open.
Hi, thank you. Happy New Year, everyone. Just a couple of numbers questions maybe you can help me with. How many motors are involved with tensioning the sunshield layers, and does each layer have a separate set of motors, or do all these motors tension every layer? And also, of those 344 single-point failures that you've talked about so many times, you mentioned 77 to 75% will be retired after the tensioning. Do you have an approximate number or percentage that's retired at this point going into tensioning? Thanks.
Unfortunately, I just looked at that number before I came up here, and I just looked at it at the end of tensioning, so I don't really have that number, but it's getting close to that right now from a single point failure standpoint. Sorry, I don't have a more definitive answer.
If someone wants to write us emails with questions that we weren't able to give actual numbers to, we will definitely try to hunt down those numbers for you.
In terms of the motor, there are 6 motors. There's one on the plus J2 side, on the starboard side, one on the port side, and then there's 2 in the forward and 2 in the aft. And these 6 motors drive all 5 layers.
Fantastic. As I mentioned, I think we got 1 or 2 more questions with these folks in the room. Greg Robinson can stay on the line, and hopefully we can answer some of the extra questions that are coming through. But next question, please.
Our next question comes from Marcia Smith with SpacePolicyOnline.com. Your line is open, Marcia.
Thanks so much. And this is just about more detail about the actual tensioning and at what point you can stop if you sense a problem. So you talked about how you're monitoring the motors and how hot they get, but what other things can happen? Can something snag? Are there sensors throughout the sun shield to tell you that, something is not separating the way it's supposed to? And can you stop after each layer or midway between a layer? And do you do port and starboard sides at the same time? How does that all happen?
Sure. Let's see. I'll start with the tensioning sequence. We do it layer by layer. Each layer has the same sequence. We do what's known as the plus J2 side. I'm sorry, my marine terminology is terrible. I don't know if that's port or starboard, but it's plus J2, then the minus J2, so port and starboard. And then we do the forward and the aft. So every layer follows that sequence. JWST deployment is designed to stop at any point. We can stop at any time and do a little bit of a reverse and then keep going. So that's the basic fundamental design driver that we've had in the requirements. And so we can always stop if issues come up. And like I said, we have not seen any issues so far. And in fact, the telemetry are showing us pretty much exactly as predicted. So in terms of can we snag, et cetera, the observatory is designed very carefully to be snag-free, and we have tested this multiple times on the ground, and given that our telemetry matches the ground testing so well, we expect to have smooth sailing.
Great. We have one last question with Amy and Bill in the room. As I said, Greg will stay on, and we will try to get through the last remaining 2 questions as well. So next question, please.
Our next question is from Joey Roulette, the New York Times. Your line is open.
Hey, thanks for doing this. I guess for Bill or Amy, I just wanted to clarify real quick. Is the tensioning of the first sunshield layer happening right now as we speak, or do you guys expect it to begin later today? And if so, at what time? And if it hasn't started yet, do you expect the tensioning motors to get hotter if it starts? And do you have any plans to mitigate that besides, redirecting the observatory? Thanks.
So we are in the pre-activities for the tensioning. It will start later on today. We started probably around, it was after 9 o'clock, and it's about 3 or 4 hours of activities before we even get into the actual physical tensioning. They will complete sometime later on today, probably more than likely this evening, the way it goes. As mentioned earlier, if those motors start to exceed a limit that's been set up, they will be turned off. We can go tension another corner while that is cooling down, and then once it's cooled down, we can initiate tensioning again back on that motor.
And since those motors have already kind of been heated up a little more than you expected, are you also expecting them to maybe reach the limits once they start motoring?
Let's see. I'm sorry, I'm not quite sure how to answer that question, other than to say, again, that we flew to a different attitude to give ourselves more margin on the motor temperatures, and we fully expected to operate as we expect.
Thank you.
Thank you so much. We will go on to our next question. For those of you, if for some reason we can't get you as detailed of an answer right now, again, do please go ahead and send us an email to the people you RSVP'd with, and we will work to get that done. But we will try to get through the last few questions here. Also, just know that keep checking the blog. We will be putting up more information about the tensioning throughout the day. It's not up there yet, but it will be soon. So with that, we will go to the next question. And let me just check, Greg Robinson, you can hear everybody okay?
Yes, Karen, I'm on.
Fantastic. We'll go to the next question, please.
Our next question comes from Leo Enright, Irish Television. Your line is open.
Yeah, thanks very much for doing this. And I second Irene Klotz's comment that really these are very, very useful and would be welcome as often as possible. Just a quick question. I haven't noticed any reference at all to an engineering model back on Earth. At Redondo Beach or wherever. I just wondered, I mean, is there a doppelganger out there that you're playing with while you're doing all of this in deep space?
Bill and Amy still on?
No, it's all you, Greg.
Okay, so the answer is yes. We have what we call we use it two ways, the back office at the Mach, and we certainly have the back office back at Northrop. And that's to support any of the deployments and some sustaining work as well. As Amy mentioned, Amy or Bill, the test bed out there at Northrop, and we have people supporting those all the time.
Could I ask you just to describe that a little bit? I mean, is this a full-scale model, or are they individual system breadboards?
They're different, depending on what we're trying to do. The power subsystem is one system, but made up like what we would normally call a flat sat.
Great, thank you. We'll move on to the next question, please.
The next question comes from Alicia Sowers, Mashable. Your line is now open.
Hi, thank you for taking my question. You talked about repointing the observatory to cool off the motors, and I was just wondering if that new position, the reposition, has any sort of downline impacts on the observatory? Thank you.
No, there are no long-term effects. As most of you know, we're trying to keep one side away from the sun and the earth, from the heat and the light. During the course of the mission, we will just normally reposition the direction of the observatory. And so we stand within those limits as well. So no long-term effects at all.
Thank you. Moving on to the next question.
Okay.
Our next question comes from Ken Kramer, Space Up Close. Your line is open.
Hi, thank you for doing this and for taking my question and continued good luck with everything. My question is about the fuel remaining on board, if you can talk about that at all. You've done 2 mid-course correction maneuvers. You got a great pointing from Ariane. So how much fuel is on board now versus how much you expected, and that would play into maybe how long you could still operate the observatory. Thank you.
Yeah, I think Bill touched on that one. We know we have a lot more fuel than the 10 years, and a lot I put quotes around it. But what we don't know going forward is how we will have to use the thrusters and fuel to complete the commissioning phase. So it would be very premature to give a gross calculation because it'll make you feel really, really, really good because the numbers are fairly high. But as we have to use these thrusters going over the next 5 or 6 months, it could certainly reduce those numbers quite a bit. So for now, I'll say a lot more than 10 years.
Okay, thank you.
All right, and moving on to the next question.
Our last question comes from Marina Corin, The Atlantic.
Hi. Yeah, I just wanted to quickly follow up on what, Greg, you just said about the, right, you said that, after launch there was enough fuel for significantly more than a 10-year science lifetime. But was that a premature statement to make? Just hearing you say now that over the next few months, you don't know how much fuel the observatory is going to use to finish deployment. So at what point do you feel confident that you'll be able to make a determination, this is going to be the science lifetime for JWST?
It's a good question. So some of the activities are planned, like the 2 burns we had, the course correction burns. Those were planned, and so the statements we've made about fuel is subsequent to those 2 burns. So the unknowns of how we would have to use the fuel to complete commissioning for any reason, and there are a lot of reasons why we could use some fuel, to move the spacecraft around, reorient, to shake it, and so on. All of those would require some level of fuel. So the statements that I'm making now, that we have a lot more years, is after the burns that we've already done.
Well, thank you so much to everybody for joining us today. I really appreciate your time and joining us on short notice. As I said, we will continue to be updating throughout the day and the coming days. And of course, as I said, please do contact us directly if there was a number you didn't get today that we can follow up and help you with. And thank you so much, Greg, for being able to stay with us for a little extra time. And have a great day, everybody.
Thank you for your participation in today's conference. You may disconnect at this time.